Now we will talk about the graphical representation of the linear equations. As I told you in the chapter of polynomial also, if I'm having a linear polynomial or a linear equation, because I am having the two pair I want to get here. So B1, this is plus C1, this is the first equation. This is the second equation and both are equal to 0. That's why their equation. Now, if I want to plot the graph of this kind of equation, means a linear equation, on the graph, I always get straight line. So first straight line with this and second straight line with this. But these two straight lines, in how many shapes we can get that? The shape means, suppose I'll get a straight line from the first one and a straight line from the second one. How many possibilities are there? Two straight lines can be, they can be intersecting. Yes or no?
Coincide.
Yes, they can be intersecting. They can be coincident, means one over the other, from where the first line passed through and exactly from the same path the second line will also pass through. At that time they are known as coincident. This is intersecting. What it is known as? Intersecting lines. And this is the case of coincident lines. Can you tell me one more possibility is there which can be here? Two lines can be intersecting or coincident, or one more possibility is there. What should be that?
That they could not intersect each other.
That means they can be parallel to each other. They can be parallel lines. Right. So, in spite of these three cases, you will not get any other case. So, for two lines, we can have either the intersecting lines or the coincident line or the parallel lines. So, from out of these three cases, we can get any of the case. So, if you have two equations, a pair of linear equations you have, so you have to make a graph of that, and after that, if they will come in this form, means they will intersect at a point, then you will say that they are intersecting line. If they will pass through with the same path, then you can say coincident. Otherwise, if they will not cut each other at any point, at that time they are parallel lines. But is it possible without plotting them on the graph? Can you tell me how, means which type of lines you get without plotting the graph? Suppose I'm having here two equations, 3x plus 2y plus 1 equals to 0, minus 3x minus y plus 3 equals to 0. And I just draw the graph of these two equations and I can get any of the three cases. But if I want to say I want to get the graph in which form without plotting, can you tell me? We have a method by which we are not in need of plotting the graph. Without plotting the graph, we can tell that what type of lines we will get. How is it possible? Let us see. If the coefficient of x you will take, that means a1 by a2, and the coefficients of y, b1 by b2. If they are not equal to each other, at that time the lines are always intersecting lines. So the first condition is, speak up.
Intersecting lines.
Intersecting lines, but the condition is a1 by a2 is not equals to b1 by b2. Similarly, if you will get the condition like a1 by a2 equals to b1 by b2 equals to c1 by c2. That means you want to get the ratio of first a1 by a2, then the ratio of B1 and B2, then the ratio of C1 and C2. And if these three ratios will be equal, at that time on the graph you always get coincident lines. Now the third case is parallel lines. For this case, if we'll take the ratio, that will come like A1 by A2 equals to B1 by B2 is not equals to C1 by C2. So if the ratios will come in this way, then after plotting you will always get the pair of parallel lines. Otherwise, in this case you'll get coincident line, and in this case you will get intersecting line. So you should go through with these conditions. You have to put them in your mind properly.